Welcome to this tutorial video where we want to look at how we calculate the change in enthalpy when we have been given the standard enthalpies of formation. What is standard enthalpy of formation? Standard enthalpy of formation helps us to understand that this is basically the change in enthalpy that is measured under standard conditions. Now, the standard conditions are the temperature should be 25 degrees Celsius and the pressure should be 1 atmospheric pressure. So, these standard enthalpies of formation are measured under these two conditions. So, in this video, we are going to see how we calculate the change in enthalpy when you have been given the standard enthalpy of formation. The question reads, calculate the change in enthalpy using the table of this equation that we have, then the table is here that we have been given. So in some cases, you might not be given a direct table like this, but you can be given the table like the one we have shown below here. So either you have been given the table like the one we have shown here, or like this table, what you simply need to do is to look at the formula that you have been given and get the exact number of the standard enthalpy of formation that you need to work with. To calculate the change in enthalpy using standard enthalpy of formations, we use Hess's law in this way. Change in enthalpy is equal to the sum of N standard enthalpy of formation of products minus sum of M standard enthalpy of formation of reactants. In the equation, you will notice there is N and M. N and M are basically the stoichiometric coefficients that we find in the equation. So in this case, N is the 3 and the 4 here, while M is the one that we have here and the 5 that we have there. Using this equation, we'll say change in enthalpy of formation is equal to, we'll start with the products. So the first product is carbon dioxide, which has 3 there, open bracket. The change in enthalpy of formation of carbon dioxide, close bracket, plus we have water which has 4, then open bracket, the change in enthalpy of formation of water, then this we close the bracket there. We are minusing this with open bracket, the reactants, which is the first one, is the change in enthalpy of formation of C3H8, C3H8, then we are saying plus 5, then open bracket, the change in enthalpy of formation of O2. Then we close the bracket. So let's now look at these numbers that we have and we put in the formula we have written. We are saying change in enthalpy there is equal to open bracket 3, open bracket, the enthalpy of formation of carbon dioxide. We have the enthalpy of formation of carbon dioxide is negative 393.5 plus we have 4, open bracket, the change of enthalpy of formation of water. Now, when you look at the change of enthalpy of formation of water, we have 2 of them. So which one are we going to use in this question? You look at the equation and notice the state symbol that is on the equation. So the water in the equation, the state symbol is showing liquid. So we'll use the one which has liquid, not the one with the gas. Unless the state symbol was gas, we would have used the other one. So we'll go for the one which has liquid, which is negative 285.8. Then we close the bracket minus open bracket there. The enthalpy of formation of C3H8, the enthalpy of formation of C3H8 is negative 103.85, then plus we have 5 open bracket. For oxygen we are saying it is 0, then we close the bracket. Change in enthalpy will be equal to open bracket 3 multiplied by negative 393.5. It gives us negative 1180.5 plus 4 multiplied by negative 285.8. It is giving us negative 1143.2. Then we are saying this minus, we open the bracket, this one we are not multiplying it with anything, so it will be negative 103.8 plus 5 multiplied by 0, it is 0. So change in enthalpy will be equal to negative 1180.5 plus negative 1143.2. It is giving us the answer of negative 2323.7. Then this is minus this other, which is negative 103.8 plus 0, it is 103. Change in enthalpy is equal to negative 2323.7 minus negative 103.85. It is giving us negative 2219.85 kilojoules. So this becomes the change in enthalpy of this equation.